So this is part 2 of lecture 9. This is for college algebra. My name is Jorge, and in this one what we're going to be talking about is graphing techniques or transformations. So there are 3 objectives. The first one is we're going to graph functions using vertical and horizontal shifts. Then we're going to graph functions using compressions and stretches, and then we're going to talk about reflections about the y and the x-axis. So the first thing is a vertical shift up. So the base function is f of x equals x squared. And then, so we have another function, which is g of x equals x squared plus 3. And if you notice, what we do with g of x is we're just simply adding 3 to the function, to the output of f of x equals x squared. And here's the table. So the first one, the ordered pair is negative 2, 4. But we're adding 3 to the output, which is the 4, so then we end up with 7. So for negative 1, when x is negative 1, the base function we get 1, but we're adding 3 to 1, so we get 4. So the ordered pair negative 2, 4 becomes negative 2, 7. And this is what the graph is. So the black graph is the base function of f of x equals x squared. The origin here is the vertex 0, 0, and you can see this ordered pair here. And then if we go to x squared plus 3, what we're doing is we're adding 3 to the output. So this 0, we're adding 3, so it becomes 0, 3, which is this ordered pair right here. So the vertex basically shifts up vertically by 3 units. The next thing is a vertical shift down. And so again, the base function is f of x equals x squared, h of x equals x squared minus 4. So then what we're doing to the output of the base function is we're subtracting 4. Here's the table. So negative 2, 4 is the ordered pair for the base function. Negative 2, 0 becomes the ordered pair for the vertical shift down. The origin 0, 0, or the vertex of the base function becomes 0, negative 4. And this is what the graph looks like. So here's the base function in black, and then the vertical shift down here in light blue. So what we're going to do is we're going to go ahead and just graph these 3 functions on the same screen. So the base function is x squared, and we have y2, which is x squared plus 2. X squared plus 2 is a vertical shift up, which is this line here. And then x squared minus 2 is a vertical shift down, which is this graph right here. And you can go ahead and read that. So if we add a positive real number k to a function, it gets shifted vertically up by whatever k is. If we subtract it, it gets shifted vertically down by k units. The next thing is a horizontal shift to the right. So again, the base function is f of x equals x squared. G of x is x minus 2 squared. So what we're doing then is we're changing the input, and as opposed to before, what we did is we changed the output. So here's the table. So the original x, when x is negative 2, we get 4. But since we're changing the input, then it becomes negative 2 minus 2, which is negative 4 squared, which is 16. And you can see here that it does change significantly. And here is the graph. So again, if we subtract within the function k units, then it's going to be shifted to the right by how many, whatever the k is. In this case, it's 2. So black is the base function, and blue is the horizontal shift. So here we have three functions all on the same screen. So the first one, the dark one, is the base function. The x minus 3 squared gets shifted 3 units to the right, which is this function. And then the x plus 2 squared gets shifted 2 units to the left, which is this function right here. So here we have shift to the left, horizontal shift to the left. So the base function f of x equals x squared, we're going to obtain the function of x plus 4 squared. So we know that if it's a plus k, we're going to be shifted to the left however many k units is, right? In this case it's 4, so the base function, the vertex is at 0, 0, so when we shift it to the left by 4 units, it becomes negative 4, 0. The next one is combining vertical and horizontal shift. So here we have graph the function of f of x equals x plus 3 squared minus 5. So you can see that we have a vertical and also a horizontal shift here. So the first one is, here's our base function. And so the first thing that we're going to do is we're going to look at the horizontal shift. So since it's an x plus 3, we're going to go ahead and shift 3 units to the left. And then now we're going to look at for the vertical shift, which is -5. So that means that we're going to go ahead and go down vertically by 5 units. So here's the base function. Here's the 3 units shift, horizontal shift to the left. And here's the 5 units vertical shift down. So here the base function is f of x equals absolute value of x. We're going to obtain the graph of g of x equals 2 times the absolute value of x. And this is what we call a vertical shift. So here what we're doing is the original ordered pair is -2, 2, but since we're multiplying it by 2, then our output 2 becomes a 4. And you can see that we're just doubling the output. And this is what it looks like. So the black is the original graph of the original function, of the base function. And then the light blue is the vertical stretch. And it's called a vertical stretch because what happens is that the function is actually getting bigger or smaller faster. So here we have the point is 1, 1, but with the vertical stretch is actually 1, 2. The original point is 2, 2, but with the vertical stretch is 2, 4. And then you can see the difference here also in quadrant 2. So here we have the base function is f of x equals the absolute value of x. We're going to obtain the graph of 1/2 times the absolute value of x. So here's the table. And as you can see, what's happening is that we're actually dividing the output by 2. So we're having it. So here is the base function, which is the black or the graph, and then the blue. So what happens is, as opposed to the 2 times the absolute value of x, the 1/2 times the absolute value of x is what they call a vertical compression. And although it becomes wider, what happens is that it increases at a slower pace. So the original ordered pair is 2, 2, but the vertical compression becomes 2, 1. So it grows at a smaller rate. So here's what we were talking about. I'll let you go ahead and read that. So vertically compressed or vertically stretched. So if a is greater than 1, it's vertically stretched. A is between 0 and 1, it's vertically compressed. Now, so again, just to recap, and if argument x of a function y equals f of x is multiplied by a positive number a, then the graph of the new function y equals f of a times x is obtained by multiplying each x coordinate of the function by 1 over a. The horizontal compression results if a is greater than 1, and a horizontal stretch occurs if if a is between 0 and 1. So this can get a little confusing right here. So just remember, so if it's a positive number a, the graph of the new function y equals f of a times x is obtained by multiplying each x coordinate of y equals f of x by 1 over a. So here we have the graph of y equals f of x is given. So y times 2 of f of x becomes the following graph. So as you can see, what we did is we multiplied the output by 2. So let's talk about reflections about the x-axis. So f of x equals negative x squared. And so here we have the original, the base function is x squared. And if we multiply by 1, then we go from the ordered pair of -2, 4 to the ordered pair of -2, -4. And here's what the graph looks like. Another thing about parabolas is if a, or the coefficient of the squared term, is negative, it does open downward, as opposed to if it's positive, it opens upward. And so the next one is f of x equals the square root of negative x. And as you can see, here's the base function, y equals square root of x. And if we use f of x equals square root of negative x, what happens is it gets reflected about the y-axis. So 1, 1 is on the base function, and then -1, 1 is on the reflection. So to summarize some graphing techniques, vertical shifts, y equals f of x plus k when k is greater than 0. You raise the graph of f by k units. In other words, you just add k to f of x, and if f of x minus k is greater than 0, then you lower the graph. In other words, you subtract k from f of x. Horizontal shifts, y equals f of x plus h. Again, in both of these cases, h is greater than 0. Then you shift the graph of f to the left by h units, and if it's f of x minus h, then you shift the graph of f to the right h units. So you replace x by x plus h or by x minus h. So here again, y equals a times f of x. Again, both of these instances a is greater than 0. So then you multiply each y coordinate of y equals f of x by a. You stretch the graph of f vertically if a is greater than 0, and you compress it if a is between 0 and 1. In other words, you multiply f of x by a. Y equals f of a times x. You multiply each x coordinate by 1 over a. You replace x by ax. Stretch it if it's between 0 and 1, and you compress it if it's a is greater than 1. And then reflection about the y-axis and the x-axis. Y equals negative f of x reflects the graph about the x-axis. You multiply f of x by negative 1. And reflection about the y-axis, it becomes f of negative x. You reflect the graph of f about the y-axis. So the last thing we're going to talk about is determining the functions obtained from a series of transformations. So here we have the original function y equals absolute value of x. So we're going to shift it left 2 units, we're going to shift up 3 units, and we're going to reflect about the y-axis. So the first thing is to shift it left 2 units. What we're going to do is replace x by x plus 2, so then the function becomes y equals absolute value of x plus 2. Next one is shift up. So then what we're going to do is we're going to add 3 to the output. So then it becomes y equals absolute value x plus 2 plus 3, and that's going to shift it up for us. And the last one is reflection about the y-axis. And here what happens is that we're going to replace x by negative x, so it becomes absolute value of negative x plus 2 plus 3. So we start off with the original base function, which is the blue. We shift to the left 2 units, which is this pinkish color right here. And then we shift up 3 units, so it becomes this blue one over here, and then we reflect about the y-axis, and the last one is this red line right here. And so let's do this with this one function. So f of x equals 3 over x minus 2 plus 1. So the base function then is just f of x equals 1 over x. So the first thing we multiply by 3, so it's a vertical stretch. So here's the graph of y equals 3 over x. Then we replace x with x minus 2, so that means that there's going to be a horizontal shift to the right of 2 units. And then the last one is the add 1, so it's a vertical shift up 1 unit. So here we have f of x equals the square root of 1 minus x plus 2, so the base function is y equals square root of x. So the first thing what we're going to do is we're going to replace x by x plus 1. So it's going to be a horizontal shift to the left by 1 unit. Then we're going to replace x by negative x, and what's going to happen is going to reflect it about the y-axis. And what happens is by replacing x with negative x, it allows us to rewrite this as 1 minus x, which is what we had here originally. And then the next thing is we're going to add 2, so it's going to be a vertical shift up by 2 units. And that's the end of lecture 9. Thank you.